Good afternoon to everyone. This is Dr. Polaiah, working as a professor in the Department of IT, Institute of Aeronautical Engineering, Hyderabad. So I'm very glad to inform you that today one of the important topics which we are going to be concentrate from our image processing syllabus, that is predictive coding and transform image coding in image processing. So this is the topic which we are going to concentrate right now. Like we are going to see one by another simple concepts. So what does it mean this predictive coding and transform image coding in image processing actually? So how we want to concentrate here actually? So you may all of you know how we are going to be describe the image information in terms of one way to describe information redundancy in digital images is to use predictability in local image neighborhoods. The pixel intensity which we are representing f of n comma m can be predicted from the intensities of its neighborhooding pixels which we called as from one of the A image. So this image which we are going to be write in the form of pixel intensity of the objective function, which we are going to be see that intensities of neighborhooding pixels values variations and changes by the understanding of one of the total image content of the image which we called as L, and here by the help of this L we are going to be concentrated on how these neighborhood values of n comma m values are vary as n minus I comma m minus j, which varying with the relationship of I comma j, which are belongs to the capital A, which are the complete content of the image. How it may be vary, let us see. For example, you have an image, okay? We have one image which is like this, okay? So such an image, right? So in that image, with the help of n and m relation of the origin, which varies in terms of casual windows used in image prediction. So casual windows based on your selected image, okay? So the casual window which we have selected and that pixel intensity values we are going to calculate in respect of n minus I comma m minus j, where this I comma j values are the real values, real numbers. Okay. So such variation, according to that variation, you can also concentrate from one image to the other, which varying neighborhood changes. Okay, with respect to n. And let us take n is your y-axis and m is the x-axis values. So with based on that, we can start to understand about predictive coding. So we are preparing a code which help us towards to understanding how the sufficient to code to get an error. Okay, the meaning of an error which we are going to be applying the differences in between the desired values and your predicted value. So that's what we are considering here, predictive code. So that we simply says, let us suppose that it is a sufficient to code the error E of n comma m is nothing but f of n comma m minus f primer of n comma m. So this difference is called an error of the code, that is sufficient to code the error. Okay, so this value we can consider as an equation in terms of n comma m values variation. E is that quantized decoded value of the pixels which we are called as the error of e comma n. The value can be reconstructed as follows. In this sense, f suffix r n comma m e is nothing but L of f of r is here we concentrating the total content of an image which vary in terms of your predicted value. That is, if the prediction is good, the error term has a small dynamic range and substantial compression can be achieved. For the reconstruction, such a transformation of an prediction of coefficients and of the coded error is needed. Why? When they are reconstructed. So let us be going to see that how this predictive code will be help us in terms of or by the concentrating extensionally used in telecommunications, where we can concentrate it as a lossy coding scheme, and that we are going to be prepare as the quantization of the error signal always to create an irrecoverable amount of distortion which varies in terms of this block diagram. So what is this figure help us? The block diagram of you are concentrating as a in terms of what we call communication channel. So what is this communication channel? This is your channel. Okay. So in this part we are going to take your f of n comma m. Okay, and where we are concentrating this part is f dash of, that is f cap of n comma m. Okay, so what is the meaning of understanding in between these two? In between these two values, we are going to be understanding. In between these two values, we are going to be finding an error value. So how we are going to find this? So the output of this equation, what we call n comma m, and that we are processed through the later understanding of based on your required channel, which we call as a communication channel, and sending information in terms of your required manner, maybe the keeping in terms of predictive code, and that value we are going to be understanding in terms of sending as an input to it is an input towards to running through the predictor, and we are going to get your required output. So whether you got the same value or not, we are going to be understand the difference in between these two. Error is minimized and you got the output. So that is what we are understanding here. Predictive coding extensionally used in telecommunication channels. So coming to the, let me to take one example which is a simple coding example. Okay, predictive differential pulse code modulation with the entropy coding. It is a lossless coding scheme which we are performing the in terms of DPCM depends greatly on the predictor used and on choice of its coefficients values. Okay, the coefficients values which we are going to be concentrating here, let we can understand from this block diagram. Okay, what we are going to be understand from this block diagram is how we are going to be see that pulse code modulation is right now we are going to be concentration with your entropy code. Entropy code is one of the predictive code example. Let us you see you started with predictive code itself as and you sending as an error value which you got e of n comma m, and the entropy code always will be entered. What does it mean entropy actually here? So entropy is nothing but we check you cross check the quality of the your information which you are gathered in terms of predictive code output. Okay, that we once you check, then it is quality. That means the redundancy of information is reduced and required information only sending. That is the meaning of quality here. Entropy is nothing but redundancy reduces. The percentage of redundancy of information will be reduced. That information will going to be connected to the as input to the your communication channel, and you are going to be getting your output nothing but entropy decoding. So the quality information also we are going to be giving into the input to the your predictor, and it will help us to get your output as f of n comma is same as f of n comma n. So it means the error will be reduced automatically. So why here we have to consider the predictive differential pulse code modulation with entropy code, in the sense the pulse which you are giving in terms of this pulse value, width of the pulse of modulation will be very less and very fast channel information we are sending here. That is what we are going to concentrate. That's what this will be responded point of view communication channel which we are using based on predictive code will be run in a smooth way and fast. So coming to the continuation of that, we are a modification which we are going to concentrate on only f of m, that is not n comma m, f of m can be modeled as a stationary air process. So let us take that equation is here. Okay, f of m is equal to alpha of k. It is the learning factor, and the m value which varies based on your kth defined, and you are going to be add your one of the optimal parameter of sigma of m, and what are the m is varying, that m value influenced in our function also. So this help us in terms of additional Gaussian noise uncorrelated to f of m. If you suppose you compared this with the help of a natural choice for the prediction of scheme is here f of m sigma I k equal to 1 to n alpha of k f of r of m minus k. So this is equation 1 and this is equation number 2. Both equations are help us to understand how this image line can be processed by the consideration of particular model. So here in continuation of that predictive code which we are concentrating, one of the parameters is important, that is called as a error. So let the error be says here quantized error signal EQ of m in respect of mth model, that is a part of model, part of your predictive code. We are concentrating on m values, changes, variations. According to that, it is transformed to the your values. How it is transformed? Let us see. This is an equation which help us to understand how reconstructed your FR of m in terms of alpha changes of k and FR of m minus k plus EQ of m values changes. Okay, so now the prediction coefficient can be chosen by solving the set of normal equations where R of k is the autocorrelation function that we are changing in terms of your required. So here actually a little bit disturbed with this matrix. So we can you can refer in our textbook by the help of that reference textbook 1. You can help us to understand perfectly. So in the coming slides, it will be corrected also. Okay. So coming to the that what we want to concentrating in the predictive code, which is the error image, it can be obtained and quantized once the coefficients of a of I comma j are known. That is e of n comma m values. Nothing but error is nothing but always difference between your original object function which you are going to be processed in terms of your predictive process in terms of or based on the selected of communication channel, you are getting output. That output and you are given the objective values which are pop and cover, and you are going to come back together. Then there is any difference. That difference we call as an error. That error we are going to calculate by the help of this equation. So the digital image can be reconstructed at the receiver as follows. That is f(r) of n comma m is here alpha of I comma j values f(r) of n minus I, m minus j plus EQ of n comma m values are varying based on your the variation which correlation which we call very simply autocorrelation coefficients of can be estimated using the R of j. That is why here you can see this 1 by 2 power of 2n plus 1 2m plus 1 is a product value. Okay, which help us to narrate your I value is varying in terms of m and j value will be varying in terms of m, and f of k comma l where these parameters of your k are varying with respect to n and m. So based on that values are varying here, you see here k will be depend on I, L will be depend on j. Varies according to L, then we will find out your autocorrelation R value. This is the R value which is previously matrix value which we are unable to find in terms of matrix. That value is simply you can find in terms of equation. Okay, so coming to the complete information right now, the predictive code, how it is help us to find out an error value. Similarly, one more which we are going to understand the topic transform image coding. The transform image coding is also concept to use transformation in an effort to concentrate the image energy in few transformation coefficients. What are that coefficients? Few concept coefficients are f1. What are this? F of 1, comma f of 2, comma f of 3, comma so on. So that is f of L values which are varying. Okay. So the transformation which varying here from your few transformation, that is your image energy. What is this called as a image? What we call as a image energy. Okay. The image energy which transformed here, and we keeping into the bit location, the bit location which is processing here in terms of quantizer. What is the use of quantizer? Because we are transforming from your normal information, that is grayscale information, into your digitized. So where we are concentrating on quantizer, then we will get your required output of the digitized value in terms of bit location. That is a bit allocation. We get the output and we apply your transform into inverse transformation techniques. Okay, there are the transformation techniques and information transform techniques which help us to understand the transformation image code. Okay, so the main here process of that coding will process here encoding, here decoding. So that's what we call as a transformation image coding. Encoding will be there and decoding. Then we will get your required output. Simply this transformation image coding which we are going to be calculate based on your simply assumptions which we call as which we call as a vector, that will let us take let us take f is be the vector representing an image size L equal to n comma f, where L is the total image content always. The transformation vector f, capital F. So f is a vector. After transformation, we got the capital F vector is given f equal to a into your f. What is this transformation? What is this f? Your vector representation. What is this a? Which is your coefficient values which will help us in terms of total content of an image in terms of matrix. That simply I write here where a is the transformation matrix. A is the transformation matrix. The inverse transformation simply we defined as follows. F is equal to small f, that is let us a vector is equal to inverse transformation of your matrix values and transform values of f. So where it is following with one of the property of the transformation property that we call a unitary transformation. Simply we define as A transpose equal to A transpose into A star, that equal to identity matrix. Okay. So what is this? This is one of the transformation of the image coding. So where we are assume and we process. Okay. What is the use of concentrating such a transformation image coding is here very simple to understand that DC coefficient and some other low frequency coefficients tend to concentrate most of the signal energy. That is, a varying number of bits can be allocated to the remaining coefficients that we called as the transformation coefficient of f of k is k is greater than or equal to 1 and less than k, or quantified using k quantizers. Okay, so decoding is done by applying the inverse transformation to the encoded of the coefficient vector. Okay, so let us you extend this transform image coding information by assumption of one of the problems to be solved for a good transformation coding algorithm, that is simply we say as a DFT and a DCT. where we going to be have the choice of the transformation to be used is a DFT, WHT or DCT or DST, etc. The choice of image block size is to determination of bit allocation only, is a bit allocation. So how this bit allocation will be transformed? So it is nothing but by taking an image, okay, an image. This is maybe a 2D or 3D image. This image will be going to be run what we call determined in terms of DFT or DCT or DST or WHT. These are the transformation techniques. These are the I told you that previously. There are the transformation techniques which are we are going to use frequently for our digital image processing. Okay, so let me take one of the examples here. This is example actually. Example. Let us take an example. This is an image content. Okay, this is an image content which we are going to be write in terms of n by m values. In terms of n by m values, that the complete n by m values binary allocation of a 16 by 16 block cosine transformation. That is simply here we call as a 16 by 16 coefficients. Okay, that is what we call as we have 16 rows and 16 columns. If you want, you can count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16 columns. Similarly, we have rows also 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So what is 16 by 16? What is this? This is a binary allocation of a block which we are concentrating in terms of percent transformation. The image which contains the pixel values varies from first row, first column to last row, last column value. So this diagonal, these values which are vary help us to understand how the transformation will be happening in terms of binary allocation by the help of taking one of the standard image which we call as a JPEG image. Okay, JPEG image as original image, and after your transformation applied, okay, by the help of choose, we have choice of transformation coding techniques. Those transformation coding techniques are help us to process your from original image. A is the original. This is original image. Original image. Okay. This original image is transformed to right now your required transformation. We require in terms of one of the application we call as compression process. Okay. There we can understand from one to other. So transformation image code will help us without losing, without any losing any information we are sending. And also we are constantly here by the comparison of transformation image code with the predictive code, there we are concentrated on entropy coding value. But whereas in image transformation image coding, we concentrate on the coefficient values which are varying from while transform from one transformation to the other. Based on by the help of which we call as f is equal to capital A transpose into small f. Okay, where f is a vector and f is a transformation. V is a transformation matrix. So these values will help. We check with the property of transformation technique, and there we are going to be concentrated on without losing any information. The error point of view or redundancy point of view will be minimized. So this is what we can understand the major difference between predictive coding and the transformation image coding in our image processing. So coming to the based on the differences and the concepts which we are concentrated right now are mostly help us to understanding the image processing, how this image can be transformed in our required application. The required application in the sense there is we concentrate in the predictive code telecommunication, where we concentrate in transformation image coding is compression process. There we concentrated one of the technical was compression process. So based on this understanding the major difference between these two concepts, I'm going to be conclude that this complete concepts even you can refer by the help of some of the reference books which are more important prescribed textbooks. Okay, and you can understand much more examples also. Even I too can concentrate this examples point of view and the problem solving point of view in the coming classes also. With this, I want to say for your complete listen, I want to say thank you so much. Thank you so much for your patience. Okay, I'm, I can continue this class in the coming class also. Thank you so much.
Like, share and subscribe. Hit the bell icon for more updates.